66 participants. And they will explain in case of land. They explain better. Are you able to hear, please? Participants, are you able to hear? Yes. Dr. G and yes. Okay. Start. Okay. So I hope that the participants will be coming soon and joining with us. Here we have Dr. A. Sendil Kumar, who is being graduated in mathematics and been working in engineering stream for the last 16 years in mathematics and statistics. He has published more than 13 articles in national and international journals and presented and participated in more than 17 seminars and conferences, and being a member of a board of studies for framing a syllabus in mathematics and statistics at different universities of different institutions. He has a working knowledge in Python and R packages. Apart from that, he was an adjunct faculty for our RKMVERI for statistics, teaching about statistics over here. And this is all a small brief account of it. He will be covering the way in which the statistics in data science will be taken as follows. Any query, please? Any chat in chat, you can put up the any queries related to it, because some of them have raised their hands. Query chat. Yes. So any query means you can put it in the chat, please. We are waiting for that, because raising up hands, then only we'll be able to know what is a question. So we will be covering this statistics in a data science as follows. Sendil Kumar will be covering, Dr. Sendil Kumar will be covering the basics of a statistics, basic requirements of a statistics. And apart from that, what we will show you is one case study of making an application of what he is teaching it. Then later, there will be one complete case study of travels in which we are able to know the analytics part of data analytics part, how to do it with Python, so that any data set is being given. Any data set is being given. How does the data set to be taken, so that we will be able to taking up a separate data set and working on the data set and applying the statistics part of it. That is a package of a statistic part of it to make an analytics, data analytics on that. That is the part in which we will be focusing on this session. So first, Dr. A. Sendil Kumar will be going with basic of statistics, and that case studies and other things will be done by myself along with the Dinesh Kumar. So this is the overall spec of today's presentations here afterwards. Apart from that, difficult to follow Python without hands-on experience. However, we will be sharing this code with you all, please, because what we have been doing it with our MSc data science here is most of the things we will work on statistic, that is whatever being taught in the statistics, we will be working or converting into a Python coding. Apart from that Python coding, then we will be implementing and saying it. That's a way in which we have been working for a quite longer period of a time. And that's a practice in which we add it over here. The same practice we try to talk with you all in this workshop. So therefore, we will be making it out with the Python coding so that we will be explaining you each and every line. The later stages you can go about and we'll share about all these codings with you all so that you can test it up at any point of time. So now Senthil Kumar will be going with the basic statistics and we will be following with the case studies here afterwards. And if time possible, there will be some other case studies also. We will be sharing it with you as the time goes on. So apart with 2 case studies, we'll share with you for time being. The remaining case studies here is either we'll share with you or if time permits, we'll be taking into this session itself. So now it is a time for Senthil Kumar where he will be going with the basics of statistics and we'll be coming up with the case studies.
Good afternoon to everyone. I am Dr. Senthil Kumar. I am very much grateful to Director Sir and Professor Dinesh Sir offering me this opportunity. The topic that is allotted to me was statistics for data science. In this topic, I am going to cover the basics of statistics, which are very fundamentals. And then at the end of the session, at the end of the statistics part, I'm going to cover the Markovian model. Okay, here. Okay, introduction. The role of statistics in data science. Before going to my session, I like to share the realistic what happened in the last week. In the Saturday of this month, 17th of this October, the NEET results have been published. In that, 2 students have got full marks 720 of 720, and one state, Andhra Pradesh, which scored 8 toppers among the top 50, and also one state, Tripura, which scored 88,889 qualified for the NEET examination. Whether this shows any relevance to the data, these are the data. Whether with this we can compare in statistics. Here, we can talk about the state which scored the more, Tripura, which scored 88,889. We can talk it as one of the statistical model mode that I'm going to discuss in the future. And also we get out of 13 lakh students appear 7 lakh students have qualified. This we can take it as one type of data. That is, before going to the role of statistics, every data is in the form of a distribution that we cover in the later part. Okay, now in the beginning, measures of central tendency, which covers the 3 parts: arithmetic mean, median, mode. Arithmetic mean, as everyone are aware of that, right from childhood, what we are scoring the class subjects will be calculated through the methodology of arithmetic mean. That is for a simple data. But we go for large values, more than 1 lakh. For example, take the last NEET examination, it has more than 13 lakh aspirants. How we'll calculate? Okay, that we'll see now. Arithmetic mean of a set of observations is the sum divided by the number of observations. That is for the data x1, x2, and so on. Xn is given by x bar is equal to summation of I equal to 1 to n xi by n. That is adding the total, adding the data, adding the values divided by the total number of data. The simple arithmetic calculation. If that is done for, we can go for countable values. That is for our 50, 25, you can do it. If the distribution goes for a very large value, for I takes the value n equal to 1, 2, and so on, n is very large distribution. There we go for the x bar is equal to summation of I equal to 1 to n fi xi by n. Here, fi stands for the frequency. What is frequency? The number of, for example, is classified. Well, for example, the NEET exam is scored for 720 marks. So that we can classify into 0 to 60, 60 to 120, 120 to 180, up to 60, 60 marks. So that is called as XI. And Fi is nothing but the number of scores scored in, that's called as a frequency. Okay, that is for continuous distribution. Next one is median. Median of a distribution is the value of the variable which divides into two equal parts. And the median is thus the positional average. For example, if a test is conducted for 100 marks, then the middle, we cannot say that it's a data lies between 0 to 100 means we cannot say 50 is the middle part. What the exactly scoring part? Suppose some may score 0, 0, 10, 12, 20, like that goes on. Now arrange the data in the ascending order and divide. If n is an odd value, we take it as the form median as n plus 1 by 2. If n is an even, then we n plus 1 by 2 item. That is, if I take n is equal to 11 data, then the middle part of the values will be 11 plus 1 by 2, 6th item. If n takes an even value, then the median formula will be n by 2 plus n plus 1 by 2 the whole divided by item. Suppose I have 12 data, then I have to calculate the median. That is 12, if I take n as 12 means 12 by 2 plus 13 plus 1 by 2 the whole divided by 2 items, which gives the median of the given data. That is for the raw data. If I go for a continuous frequency distribution, what I have explained for the previous median, then the median formula will be L plus H by F capital N by 2 minus C. Here, L represents the lower limit of the frequency and H represents the height. F represents the frequency and N is now the total number of data, N by 2, and minus C is the cumulative frequency. Cumulative frequency means, for example, if you take 0 to 60, 60 to 120, 120 to 180, for each observations, for 0 to 60, I have 10 frequency. And 60 to 120, I have 5 frequency. And 120 to 180, I have 7 frequency. Cumulative frequency means we have to add all those. I'll explain later on with the case studies. Okay. This is called as median. Median for continuous data. Mode. Mode is the value which occurs most frequently in a set of observations around which the other items of a set cluster densely. For example, Tripura, in the NEET examination, Tripura have scored 88,889 students for the NEET exam. So that we can take it as a model class. The mode for the distribution of the states, Tripura takes the mode form. Okay. Similarly, for continuous frequency, the above formula can be applied. Mode is equal to L plus H into Fk minus 1 divided by Fk minus Fk minus 1 plus Fk minus Fk plus 1. Where Fk is the corresponding frequency, Fk minus 1 is the frequency preceding Fk, and Fk plus 1 is the frequency after the frequency. This is called as a mode. Next part is quartiles, deciles, percentiles. This is somewhat related to the median. Okay, the median.
One second. Audio visible. Audio
are you able to hear, please? Audience?
Check chat. Yes.
Okay, thank you. I continue. Quartiles, deciles, percentiles, these are somewhat related to the median part. The formula for median is, just listen to the median. Here median is equal to L plus H by F into N by 2 minus C for median. For quartiles, I apply quarter part. That is, for first quarter, I take it as N by 4. Second quarter is 2N by 4, which is nothing but N by 2. Second quarter is nothing but the median. And third quarter, we take it as 3N by 4. Okay, which gives the quartiles. That is the dividing the distribution of the data into 4 equal parts. That is called quartiles. That is 3 points. We'll divide a line into 4 parts. Next, deciles. Deciles is nothing but the same process like that of median, like the quartiles median, where we apply, see, take the formula. Instead of N by 2, I take for first deciles N by 10. Second is 2N by 10. If the fifth decile is 5N by 10, which is nothing but N by 2. That is, fifth decile will also be median. Okay. So D1, D2, and so on up to 10th decile respectively. percentiles. The 99 points which divide the series into 100 parts is called as percentiles. That is the 99 point, that is versus median divided into 2 half, quartiles divided into 4 half, deciles divided into 10 parts, percentiles dividing the distribution into 100 parts, equal parts is called as percentage. Here if we apply in the part of n by 2, we take it as n by 100 for first percentile. For 22nd percentile, 22 n by 100. For similarly 100 means 100 n by 100, which becomes n, which becomes the last part of the distribution. Okay. Now we go for skewness. Skewness means lack of symmetry. Symmetrical curve, if you draw a structure, means it will distribute it equally in the 2 parts. It is divided, the structure will be divided into equal parts. We study the skewness to study an idea about the shape of the curve which we can draw with the help of the given data. The distribution is said to be skewed if mean, median, mode fall at different points. Quartiles are not equidistant from the median. That is, from the middle part, the quartiles does not form in an equal distance. And the curve drawn with the help of given data is not symmetrical. Symmetrical means the curve, you have seen about the normal distribution curve, which is the exact form of a symmetrical distribution. Here, 1 point in the negative part will equally distribute in the positive part. So, in skewness, the symmetry will not be given. Okay, for this, we'll show a diagrammatic form in the later part. And kurtosis. Kurtosis enables us to have an idea about the flatness or peakness of the frequency curve. It is measured by the coefficient beta 2 equal to mu 4 by mu 2 square, which is the mu 1 is mean, mu 2 is calculated variance, and mu 3, mu 4 go for higher level. So kurtosis gives the shape of the curve. We take the second one as mesokurtic. If beta 2 is equal to 3, means it is nothing but the normal distribution. If beta 2 is greater than 3, then the peakness of the curves will be increased to higher value, which shows high peak. This platycurve means below the normal curve. That is, curve being a flat form. Okay. Covariance. If x and y are 2 random variables, then covariance between them is defined as covariance of x comma y is equal to expectation of xy minus expectation of x into expectation of y. This expectation of x is nothing but mean of x. Expectation of y is nothing but mean of y. If capital X and capital Y are independent. Here independent means x and y are 2 different attributes. X is not dependent on y and y is not dependent on x. Okay, in that situation, expectation of xy is equal to expectation of x into expectation of y. And in this case, covariance of x comma y is equal to 0. What is the importance of covariance means? It's for next session, next topic, correlation coefficient. This covariance plays an important role. Pearson correlation coefficient or coefficient of correlation. In a bivariate distribution, if the change in one variable affects a change in other variable, the variables are said to be correlated. That is, we have to make some correlation. That is, take an example. For example, we take an example of if you invest more in advertisement, the sales will be what is the output of the sales. That is that shows the relation between the 2 variables. That is the performance of the students and the performance in the organization, or performance of the students in this internship. You can correlate within any 2 x and y data. And one thing, keep it in mind, correlation coefficient always strictly lies within -1 less than or equal to or less than or equal to 1. If it is +1, then the correlation coefficient is perfect positive correlation. And if it is -1, it's perfect negative correlation. And if R is 0, then there is no correlation between the 2 data. Normally, we won't get in terms of -1 and +1, but the value of lies in the region -1 to +1. If we get a result of -1 or +1, then it is perfectly positive correlation or it is perfectly negative correlation. Then linear regression. The line of regression is a line which gives the best estimate to the value of one variable for any specific value of other variable. Thus, the line of regression is a line of best fit and is obtained by the principle of least squares y is equal to ax plus b. This y is equal to ax plus b is a straight line equation. That is, normally we plot the data in a two-dimensional graph, and with the collection of the data, we plot a straight line, which we can say that whether the data are nearest to the data are nearest to the straight line. If it is deviated from the above, we can say that it's not correlated. So correlation and regression have somewhat relationship. And the line of regression of y on x. To calculate the y, if x is an independent variable, the formula is y minus y bar equal to r into sigma x by sigma y into x minus x bar. Here, y bar represents the average of the data y. R represents the correlation coefficient, and sigma x denotes the standard deviation of x, and sigma y denotes the standard deviation of y, and x bar is the average of the data. I'd like to say what is my standard deviation. Standard deviation means on average the data deviates how far from it. For this, I can give an example. Okay, if your company is offering in a sales of 1,000 bulbs, and assuring that the quality of the bulb is around 500 hours life cycle, but none of the product can satisfy at most 100, because it may be more than 500, it may be less than 500. So that is called a standard deviation. Okay, now the line of regression of x on y is x minus x bar into r into sigma y, a small correction, sigma y by sigma x into y minus y bar. Here same representation for line of regression of x on x. That is, x depend on y. We use this formula for this regression equation. And multiple linear regression. Multiple regression model is somewhat higher level than the regression model, which describes how a single response variable y depends linearly on a number of predictor variables. For example, the selling price of a house can depend on the desirability of the location, number of bedrooms, the year of house built, the square feet of etc. So here, y represents the selling price of a plot, and x1, x2 represents the location, x2, if you assume x2 has number of bedrooms, x3 has when the house is built, x4 is square feet, etc. So then to predict one dependent variable on multiple independent variable, we took the multiple linear regression model. With this, I will go a case study regarding the statistical model.
Just we will go with the case study related to what the talk being given by the Dr. A. Sendil Kumar. Here we have been talking about win equality of GSV file, where we will show you the data set. Let me explain you the data set first, and later we will be going by line to look upon that what it is. One second, please. Inequality data set. Yes. ಇದು ನೀವು data set. Excel sheet open. Few minutes, please. CSV files. All fields, all fields, all fields. Oh, shit. 15 chats. So this is your data set in which we are having the following fields. That is, this is a wine data set. The quality of the wine is your dependent variable, whereas the independent variable, this dependent variable depends upon this following fields: fixed acidity, then you got volatile acidity, then you got citric acidity, then you got residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH value, sulfates, and alcohol. So these are all the fields in which this quality is going to be decided. So therefore, taking up this study, applying the basic statistics of what Sindhil Kumar has said, we'll be applying it in our coding of which we are having it or which you are seeing it now. Okay. Sure. This is the win equality rate CSV file, which has got certain parameters, that is fixed acidity, volatile acidity, citric acidity, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, and quality. So this is all the packages being used for the evaluation part of this data set: pandas, numpy, seaborn, matplotlib. This pandas is for the defining the framework, numpy for calculation, seaborn on matplotlib is for my visualization and other parts. So the first step here is how to read it. It is here data frame, we are giving it CSV file which we can read it. Either it could be a CSV file or it could be an Excel file where you will be reading this, and you will be using the packages directly over there in Python rather than using a coding way of a coding or in C or C++ we write a raw code to calculate a mean, median, mode like that. Like that we won't be doing it. We'll be giving you a certain, what we call it as a function name. Immediately we'll get about mean, median, mode of all the parameters being shown to you in this data set. So here the first thing what we give here is we use df. Df is nothing but a data frame where we use it from the function called pandas to read that data file where it is being stored in the data frame called df. Print shape. This line called df.shape will give me number of records and the number of fields. That is 1599 records is there and there are 12 fields. And what are the fields and what is the data types of these fields? Yesterday in morning session, if you see that Sandhya was asking you a certain questions such that about the data types of your Python, there are different data types. You got even a complex 128 is another data type which you got it. But such data types, we are not using it in our real time, but there are certain places in which it is being used. Here in this case, by default in this data set, which is given as a CSV file, Python itself will take about the data types required for that respective field. Just I am reading you only the CSV file. I'm not reading, I'm not defining what this field is and what this type of data field is, which is not at all being done. It is being done that just we given an input of your data set, that data set taking up in the pandas, he will decide which is a suitable data type for that particular file or particular field. That is the way it happens over there. So df.shape will give me the number of records and fields. df.dtypes will give me the what we call as data field. If you observe it, we have got nearly about 12 fields and one is a dependent field. Fixed acidity, volatile acidity, citric acidity, residual sugar, chlorides, free sulfur oxide, total sulfur dioxide, density, pH, sulfates, alcohol, quality. All these things are being given to you over here. if you observe it very keenly, all those data types are being set or taken as a float 64. Because it is having a decimal point, automatically it has been taken as a float 64. Whereas if you see the quality is being referred as a 5 or 6 or 7 like that. Therefore, it is being taken as an integer data type. Now, if you observe it, DF shape is over, D types is over. That is minimum, mean, median, first quartile, second quartile, and third quartile, which was explained by Sendil Kumar, is being given in a single line called df.describe. So in this df.describe, when I give it, immediately all the fields is being taken: fixed acidity, volatile acidity, citric acidity, residual sugar, chlorides, and so on. Count, that is number of elements, that is number of records in that data set. Mean of that, standard deviation of that, minimum, maximum, 25 percentile,
Q1,
Q1,
Q2, Q3.
Q1, Q2, Q3, and so on. So these things are all automatically being taken if I am able to give a function name called df.describe. This is one of the part. If you can ask me that whether the statistical part we have to write a raw coding, all those things we can avoid it, since Python is a powerful language in which there are set of libraries in which we can use it, and we are using it. Now, this is one case study I'm talking about it. The second case study, I'll be taking it up in such a way that more analytics part will be there, where we will be doing a much more better way of an approach, where we'll be using certain packages called SkyKit, and we'll be using another package called Stats Model. So here, when Sendil Kumar was talking about a correlation, the correlation is being given in a very easy form. That is, you have a formula n into sigma xy minus sigma x sigma y and so on. Whereas this is being given as df into correlation, where when we print out that one, if you see it, the fixed acidity with the fixed acidity is 1. Fixed acidity, volatile acidity is being given. Fixed acidity to citric acidity. All the values are lying in between -1 to 1. If you see it, that is a relationship between a density and fixed acidity. And if you see about what is the quality, if you are going to concentrate on the quality, there is a possibility of a fixed acidity where with the quality is 0.12, whereas in quality, volatile acidity is minus negative correlation. So whereas which we get a citric acidity is a positive correlation. For residual sugar, it is a positive correlation. Residual sugar with the quality and chlorides with the quality. Similarly, sulfur dioxide with a negative correlation. So the impact of it may be less when it is a negative correlation. But if you see about the pH values and other things over there, there may be a negative, but we have to see into the way in which the distribution, normal distribution is also being there with it. So correlation, if you see it, there is a correlation between each and every field automatically being taken or being given to us using df.corr. So correlation part, where the respective fields will be taken and all the fields, 12 fields will be taken with respect to the another 11 fields, it will be correlated and it will be displayed. So this df.correlation is a function name being used over here to find out which field is more correlated with another field. Whereas that is what we call it as, if you see upon that alcohol with the quality, it is 0.47 is having, that is alcohol is having much more influence over the quality. Whether such thing is allowed to have it, or such thing will be able to look upon this while we are using a normal distribution curve, that we have to wait and see. As we are going on, we'll look upon that also. So this is the first part which we have seen here is the number of data available in your data set called df.shape. And second part, when we are seeing it, we have been talking about the different data types, which will be taken automatically by the data frame, which is being used as a package from pandas, where it will decide according to the field name, according to the content of the field, which data type is suitable. And then the describe part, which will be talking about the minimum, maximum, first quartile, second quartile, third quartile, and the median, and so on. So third part. After applying correlation, what we can understand from the. Yes. See, that is a question that. That is a question that how far that is after applying correlation, what can understand from the output. That is some kind of a relationship we will be able to find out between the different fields. That is the understanding. Suppose here is the thing which I want to say you here is alcohol is there, and we are talking about the quality. That is, quality becomes a dependent variable where the alcohol is having a 0.476, that is 0.48 correlation. This correlation is having a better correlation than the other fields. And there are certain fields in which fixed acidity and density. So density and fixed acidity are going together, that is 0.66, which is having most positive correlation. Please.
One thing, you look after the similar data. Last session seen about the similar data. Alcohol which gives 1. Because if alcohol value, if the alcohol value gives 1, that is not a correlation. That gives same data gives perfect correlation.
Is co-occurrence is equal to correlation?
Co-occurrence is no.
Co-occurrence is equal to the correlation?
No.
Say sometimes, no, we don't think so that. So sometimes it's not working about it.
What is co-occurrence? Co-occurrence.
There is data will be occurring simultaneous. That is what we call it as a, suppose you got a fixed acidity, volatile acidity, the occurrence of those data will be similar sometimes.
Okay. So see here, this correlation is for same data, it gives 1. Whereas this gives negative, this density of alcohol gives negative correlation because it gives both is negative results. Whereas sulfates with alcohol gives positive value. That is nearest to 0 but somewhat positive value. So it gives positive. That shows that when it's negative means there is the correlation between the two data is very, very less. Whereas positive means it gets matching in a perfect way.
See, correlation is one of the what we call statistical technique to evaluate or find out the relationship between the fields. In given any data set, the first application we do it here is we apply a correlation. Later only we will be applying a different types of statistical analysis to find out the data. That is relationship between the or among the fields. Next. Anything else, please? Anything else? So, anything else? So, based on this, we will be going to the next part. This is somewhat a coding. Don't be getting perplexed by this coding part because there's nothing to do with the statistical part directly, but it is having a meaning to be done while we are writing while we are making an analytics or analysis on the data set. What is this part here is, we may be having, suppose this alcohol and other things I have given you, citric acid, volatile acid, residual chloride. These are all the numerical data. So there is no problem in that case. Suppose I give you data in which there is some kind of an name, age, gender, everything, if it is going to be there, then there is a problem over there. We have to separate between a string and a numeric. We have to select only a numerical data. And on that numerical data, we have to apply a statistical block like mean, median, mode, and other things over there, and the correlation. For that, it should be automatically done. If I given you a data set, that data set, our coding has to find out which is a numerical part of that data or which is a string part of a data. To find out a string part of a data or a numerical part of a data, this is the way in which the coding has to be typed. That is df.select dtypes include np.number. If I give it like this, that is enough for us. It will select all the fields. It will select all the fields only related to numeric. It will not select any string data. String data means either it is a gender, male, female. If I give it, that field will not be selected. And names, that is K7, Govindan, like that, names are being given. That also will not be selected. That is the reason this coding is being there, where to select it. Why do we apply this coding? It is while we are writing the coding, we thought that only numeric fields should be taken. That's the reason we have taken it over there. This year in this part, that is the part in which it is being aware. And we have been what we call it as rounding it about the 2 fields over there. If it is beyond that, we round it about the 2 decimal points. So this is the part in which it happens over there. Next. If you look upon the skewness and the kurtosis, which was Indil Kumar was saying it. So this is the part in which skewness is being given. A fixed acidity, volatile acid, citric acid, numeric acidity. Skewness is lying between -2 to +2, and kurtosis will be lying with -3 to +3. If you observe it over here, all this data, certain data like free sulfur dioxide and total sulfur dioxide is lying between -2 to 2, whereas residual sugars and chlorides are lying beyond -2 to 2, where these fields I need not consider about it. If needed, these fields we can ignore it and do something. So our concentration may be on any of these fields. Similarly, when we look upon this kurtosis, That is minus 3 to 3. Minus 3 to 3 means if you take about residual sugar, here also residual sugar is got removed. And similarly, residual sugar, chlorides and other things have got a larger value. Sulfates has got a larger value, which we can get rid of it. There is no meaning of having it over here. So in this case, we are able to do some kind of a process as a basic statistics itself to get rid of the fields which is not having any relationship over there. Suppose if I see that the residual sugars or the chlorides, is there any correlation between them? Whether residual sugars and chlorides is having any positive correlation or a negative correlation, we can go up and see that. Residual sugar, once again, residual sugar with chloride.
Yes.
0.05. That is a correlation we are not able to say, but it is having some correlation. So correlation says that there is some relationship between residual and sugar, but when it comes to the skewness and the kurtosis, is making it very clear to us that it cannot have any kind of what we call it as an analytical part. It cannot be much usable, but still we got some kind of clues on this because of this basic statistical analysis which we are doing it. So second part here is, once we go up with this skewness and the what we call it as kurtosis, where it lies between minus 2 to 2 and minus 3 to 3, we are able to decide upon which field, and correlation also giving some pictures about the field relationship. Based on these principles, we are able to see what is the distribution or a probability distribution of each field, whether it is normally distributed or not, how far it is skewness is being there, how far the kurtosis is playing a role on that. So this is the distribution at one stroke we get for all the fields. How does we get it over here? Normal distribution, PPT.
Normal distribution, PPT.
Yeah, if you want to explain it.
Just explain. Okay. Normal distribution. A random variable X is said to have a normal distribution with the parameter mu. This is average, and sigma square is variance, the square of the standard deviation. If it's PDF, the probability density function is given by the probability law. F of X is equal to 1 by sigma root 2 pi exponential of minus half into X minus mu over sigma power 2, where X lies in the interval minus infinity to plus infinity, and the average lies in infinity minus infinity to plus infinity, and the standard deviation value greater than 0. There is a normal distribution that we can, that is a distribution is a symmetric part. There is any statistical data, if it's normal distributed, means it has symmetry in both the x-axis and y-axis, that we show it in the figure.
Yeah. Now if you see it, the plot of subplots of 2, 2, a figure size of 15, 10. That is, it is in a single figure, we are getting about, if you count it, we'll be getting 6 in the top part and 5 in the down part of all the fields. Here, if you take a length of a DF3, when you talk about it, it is a number of fields which we are having it, 12 fields we have got it over there. And distant plot, this is called as a SNS. SNS is nothing but a C-bond where we declared it in the earlier part of it. That is in the starting part of it, we declared or imported in a package called C-bond in SNS. Is this available in the pandas and numpy if you say it? No, it is not available. So that is a reason why minimum requirement of understanding for any data and minimum understanding required for any basics data analytics. For using a basic statistics, we require to know about pandas, numpy, C-bond and patpopulate. C-bond is the one of the part in which is being used so that we will be able to know it over here by the distribution part of it, whereas we are able to see that a subplot, forget about this thing. This is all the coding part in which we are doing it. Subplot means in a single plot. Single plot means this whole area is being considered. In this subplot is being given. The number of rows and columns has to be decided. The number of rows we take it is, this is one row, this is second row. The number of columns we take it is first column, second column, third column, fourth column, fifth column, and so on. So we got nearly about 11 fields over there. 6 plus 11. 12 fields over here. So in this 12 fields over here, then we have got a plot over there. If you look upon that, fixed acidity is having this plot.
This is not symmetric. See here, it's not equally distributed. Even though it's in the shape of a normal distribution, but here the symmetry is not perfect in both sides. And also we have skewness is also not. The skewness means the curve nature. The curve is not in smooth form. Okay, so this is the shows the skewness and kurtosis, and it's also not normally distributed. But see in the bottom, whereas density and pH, based upon data, it shows a normal curve, which is leptokurtic, that is above the normal curve. That is not normal. It's a normal curve, but the curve, the peakness, the kurtosis value have been increased here. But the skewness and symmetry are preserved to density and pH. Whereas for the other sulfates, alcohol, whereas it does not have any symmetries or not, and the kurtosis and skewness are failed there.
So this is about the what we call it as a density and pH, where we have got a much more better way of a result, which may be having a better influence on the quality, instead of which is if we look upon that while you are using a correlation, where we will be able to see, if you see it in correlation between pH and density, it approaches being a -1. But when we take up over there in kurtosis and skewness, whereas in skewness and kurtosis, when you look upon density, it is very well 0.07, 0. -19. And when we look upon pH and over there in kurtosis, 0.93, 0.080. But when we looked upon over there in residual sugar and chloride, there was a positive correlation 0.0 something. But when we look upon a skewness and the kurtosis, we are able to deviate a lot, 4.54 and 28.61 and so on. That means in this case, kurtosis and skewness is able to decide much more better factor than the correlation. But we can't say like that immediately. It is all depends upon the data set and the data being there with us. Based on those only, we will be able to understand it better way. So in this case, when we look upon from this normal distribution curve, that is probability distribution plot for normal distribution, we are able to see that density and pH is nearby what we call normally distributed than anything else. So skewness, kurtosis and normally distribution curve is able to inform us or given an information that pH and density is much more better field on quality rather than what we call it as a chlorides and sulfate dioxide and so on. So based on these principles, that is that these are the overall glance of what we call it as a mean median mode, then what we call as a correlation, skewness, kurtosis, and then we got about what we call as a normal distributions. So based on these principles, when we is talking about it, he talked about the linear regression. So in this linear regression, if you look upon that, this is being written in a what we call it as a much more better way. That is, we have to use again, we have to use a different packages. So that packages, when we are practicing it, when you are doing it again and again, only we get accustomed to us which package to be used, which will be much more better efficient package to understand the linear regression. We'll be able to understand it. Because when I am using normal packages of NumPy, Pandas and Matplotlib or anything, NumPy and Pandas is a basic package in which we can make a data to pull from CSV files or Excel file or any data set files, where it could be even XML or anything else. Whereas when we are using some kind of a correlation, means we can use a Pandas itself. For mean median mode calculation means we can use a NumPy itself. But when we are using some kind of an analytics plot like a normal distribution, seeing in the single row, means we have to use a C-bond, which will be having a better visualization. Whereas when it comes to the regression, similar part when you are doing it, the stats model is helping us to do this part using a QQ plot. That is helping us to understand in one stroke about the relationship between the field and the regression line and the field. So that is the next part which we are looking at in a linear regression, which was being explained theoretically by Sendil Kumar. So in this stats model, the similar way we are using it, instead of this, we are using one plot called as a QQ plot. This QQ plot will help us to understand what is the relationship between the field and the linear regression. That is a plot and the linear line being drawn on this. So you got about a fixed acidities by saying that there is a lot of outliers beyond it. And if you look upon the volatile acidity, there is a outer line. Most of the points are lying on the line and some of the points are lying outside it. But when we look upon the lower part, citric acid, similarly, there are most of the points are lying outside the line. And residual sugar, chlorides. See, the chlorides and the residual sugar, when you see upon in the correlation coefficient, there was some relation called 0.05 something. But when it comes to the part in which kurtosis and skewness and normal distribution, it showed me clearly that it is not having a relationship. When it comes to the linear regression equation, we are able to see that these points, or that is chloride sulfates, are not having any relationships, is going beyond it. So now you can see about the pH and the density, which we are looking at from skewness, kurtosis, and normal distribution over there. So density part, some of the points are lying outside and most of the points are lying on the line. Whereas in pH, we have got the similar pattern. So pH and the density is really a clear indicator for us that it is playing a very good role of a deciding factor or a decision making factor for quality purposes. So that's the way in which a linear regression helps us to understand it about it. So this is an overall glance of what we use it in a linear regression, in which we are able to see in the linear regression a relationship between the points and the linear line which is being drawn over there, and we are able to study on that. Whether we will be able to get the equation, we are able to predict on that. Yes, we can do that, and that also we will be doing it with the two models. One is called as a OLSL model, stats model also. One another is a sky kit. Will be using it for that purposes, which will be saying it soon now. So this is the overall part of it. Now you get into a multiple linear regression in which multiple linear regression over here, where you will be seeing it as an example part of it. Once again.
Just explains last linear regression. Why it's line plot, the quality.
Quality.
Why that shows this?
No, that is because
that is because of
data.
Okay.
That is because of the data. That's not 5, 6, 7. No, that is
only 5 output value.
Yes, that is not the thing. So when we look upon this over here, that is the question was here is whether why does the quality that is being there, because this quality is having 5, 6, 7 and so on, that is being drawn like that. That's the reason. So multiple linear regression in which we take it up now. In this multiple linear regression, we use two methods over there. One is called as a sklearn, another is called as a stats model. Each and every step we will be seeing it now. Here we take up a data in a different way, where we declare a data instead of taking it from a data set. Yes, if you want to take it up from a data set, yes, it could be taken here. Where in stock market, we have got a year, 2017 and 16 data, whereas for that month, respective month of 2017-12, we got an interest rate and unemployment rate, stock index price. Stock index price is an independent dependent variable, and unemployment interest rate is a independent variables. Whether this stock index price is having any relationship with interest rate, stock index price is having any relationship with unemployment rate, stock index prices are going to have any impact because of using interest rate and unemployment rate, where that comes the multiple linear regressions. So in this case, we are going to talk about stock index price influenced by interest rate and unemployment rate. So first we take about this data, forget about these data because these are the data being given to you, where we create a data frame based on this. This is a kind of a coding which we have to use it from Python. This coding part on this file will be shared today itself. It will be sent to you. You can either use a Jupyter or you can use any Python editors to evaluate this, so that you will be able to understand it better. So next year is when the stock index price is an independent variable and the interest rate is a dependent variable. Here if you use it, see in a linear regression, you are using a stock index price and the interest rate, what will be its way in which it can happen. See, two things we have to understand it over here. It is the way of approach in which it is being done. Here we use NPy, that is NumPy over there, to find out a relationship between the interest rate and the stock index price as a linear regression. So we use a plot scatter. So then we use a grid and other things over there. Then y, that is mx plus c, that is mx plus b, we use it over there to plot it. So we find out the relationship between a stock index price and the interest rate. We don't find any kind of a relationship. We can see that there is a vertical scatter plots over there, and we are not finding out a much better way. But whether there is any kind of an stock index rate, index price is having a relationship with the unemployment, yes, there is some kind of a relationship of unemployment rate and stock index price. But here the concept here is, these things are nothing but a coding part in which we write it. This is nothing to be more concentrated, title, label, and other things. The two part which we have to concentrate here is polyfit. Polyfit, when I say it, it is a NumPy function in which X and Y data it will taking it. One, when I give it, is a linear. Two, when you give it, it is a parabolic state it will go. Second degree equation. Three, when you give it, going to give you some kind of a curvature or a curve. It's a third degree equation. So polyfit is one of the best function available in NumPy, where we have to do all this part. See, the part here is, here when we use a NumPy, we have to use plot, scatter, plot, title, everything you have to write a coding to display it in a graphical part. Whereas in QQ plot, I gave you only a QQ plot and I give you only the data. DF3 is a data set, that is whole data set for 1539 data to one stroke. I'll be able to get all the graphs within these 4 lines. That is the advantage of using a different packages, I said. That is, it will take a quite longer period of a time to understand which package is much more better way, which package to be used effectively and efficiently, so that we will be able to get a visualization at one stroke of a time. That is a quite, it will take some more time for us to understand it. This is being a workshop, we are just explaining you what is what. That's all we are doing it, nothing else more than that. So let me go back here again. So this is the part called as a NP, that is NumPy. We are using a polyfit, where we are using it to display it over this part, where it is finding out a relationship. There is some relationship between unemployment rate and stock index price. Whether linear regression you are able to get it over there, yes, we are able to get it a linear regression over this part. Whereas multiple linear regression, in which we are going to study about the interest rate and unemployment rate, both the things on a stock index price. Whether we will be able to get it up, the influence of a stock index price using interest rate and the unemployment rate, where we use two functions over here. One is called as a SK-learn, where we will be using this package to understand a linear regression for multiple linear regression. Don't think about it as a multiple linear regression means single function or a y equal to ax plus b and so on. It is for multiple linear regression. This is the model which we are using. So regression equal to linear model fit x comma y. If you see that and if you run this coding, immediately we'll be able to get intercept coefficient. That is, intercept means we got an a plus b x1 plus x2. So intercept is nothing but a, and this coefficient is nothing but b and c. So the equation is nothing but this is the equation which we are getting it, which we call it as a multiple linear regression, where x1 is referring for interest rate and x2 is referring for unemployment rate. Whereas if you take upon this, when we supply any kind of a new data, that is interest rate is 2.75, and if I give in new unemployment rate is 5.3, what will happen, or the prediction which we can make it up on this. So once we not only are going to represent it as a graphically using Seaborn or SNS, but when we want to calculate a predicting value of this, yes, we will be able to do that. That is called as a predicted stock price for this new data called as interest rate and unemployment rate. We are able to do this. Similarly, we can do it for a linear regression for single variable, that is single variable dependent on a single dependent variable. So the next part here is either it is possible to have this linear regression, that is multiple linear regression using a SK-learn. Instead of that, is it possible to use the same thing over there using a stats model? Yes, you can use it over there, where you can use least square method. Then polyfit equal to 2, just will be, if I run it now, it will take some time. Instead of that, tomorrow we will take you a same case study over there, put a polyfit equal to 2, shows you polyfit equal to 2, 3, 4, 5, 6, 7 also. Then I will be showing you one program completely run on this basis. Please give a time tomorrow morning, we will be writing the coding part and will display to you. Now if I run it or change it over there, the whole change will be coming over there, because we have to run by line now, right from the beginning. Because Jupyter notebook, while I am running it, I have to run from this part onwards. That is, I have to, because I have run it on already and kept the results directly. Therefore, I will be running it from the beginning tomorrow. So This question, we make a note of it. Tomorrow, as a starting time of this, we'll be running it over. So now, if you look upon this with the stats model, this is another model in which already we have used this stats model to see with the linear regression one stroke called as a QQ plot. Similarly, we can use this stats model where we'll be getting online least square. This is the most model which we are doing it, where you got a predictions, where we print out this one model predict when we give it of all the data present over there. Immediately we get a OLS sheet immediately, where we'll be getting a coefficient of your constant, that is called a B interest rate and an employment rate. Apart from that, we will be able to get your extra data, correct R squared and adjusted R square, where you will be able to know how far this data set is there. When this R square is in the one and over things over there, near is 0.98 means it's a data set is good enough or that is what a consistency over there. So similarly, these things is able to understand it in a much more better way of the regression results rather than using a sklearn. So it is our to decide it whether the packages of a sklearn could be used for a linear regression to understand it, or it could be used for the stats model. It's all up to us to decide it, which could be get while we are doing it, start making an analytics part of it. So based on these principles, we go to the next part called as a logistic regression. So logistic regression. This logistic regression, before getting into it, let me get into the data set of the logistic regression, social networks. So this logistic regression. So in this logistic regression, we have got user ID, gender, age, estimated, and purchase. So nearly about, if you look upon this data set, it is running like anything. We will be getting more than 500, 300 data and 400 data. So that is a question in which how to choose a type of a regression for a particular operation. See, our request here is don't choose any kind of a regression or anything. Apply that regression over there. For example, go to my coding, please. See, please, my request here is don't think about how to choose a linear regression or anything, because we can't understand it, which data is related in what way. So therefore, my request here is go back here, set up a coding like this. This coding, by showing the coding, this is the coding. This coding, my thing here is how to select a linear regression. It is not the major part of the question. Here is this coding will help us to find out the relationship between the fields and draw the linear regression suitably for it. So once the suitable linear regression is being given by the QQ plot, from this one we will be able to understand which field is more correlated, that is regressively correlated or not. That is in regression equation, whether that scatter plot with the linear regression, that is equation, is more suitable or not by seeing it. This is the equation, because we have written it in a generic way, such a way that these 4 lines of coding, just you give, that is what you have to give here is this DF3 should have your database. That is what we call it as any CSV file. Any CSV file or an Excel file, when you plot it to this CSV file, this DF3 automatically don't change any coding. This coding is sufficient enough. This 3-line coding is sufficient enough. Either you have a 12 fields or 24 fields or 36 fields, it will plot up a graph in such a way that which field is having more regressively or being what we call the scatter plot is being more on the regression line or not. So this will help us to understand it, which regression equation is much more better. Okay. So therefore, we'll come back here. That Excel sheet which we have opened here. Oh, open one more, 3P. Share. Yeah. So in this data set, we have got around what we call it as gender, age, estimation, and purchase. This age estimated is nothing but a salary, estimated salary, and purchase. Purchase refers for an since being a logistic regression equation, logistic regression, where we talk about either it is true or false or 0 or a 1, where this purchase is whether this age of a person who is getting this much of a salary, whether he will purchase it or not. That's is the question for this data set. So the question should be very clear when you are taking up a data set, or what is the output we wanted, what is the input we are having it. If output which we are expecting it, if doesn't have a proper inputs means then we are not able to arrive at the proper outputs. So this one is a very simple problem that whether this age having this salary, whether they will purchase this or not. What is to be purchased? It may be a credit card, debit card, or anything else. It could be a goods, or it could be some kind of a materials, anything it could be. So based on these principles, whether we can work it on this logistic regression. So yeah, we have got so this social networks, social as a CLC file is having a ID number, then it is having a gender, then it is having a age, then it is having a estimated salary, and it is having a purchase, either it will be 0 or 1. So based on this age and estimated salary, whether that goods could be purchased or not is our decision. So we are reading the data file. Here is the one part of it. Beautiful part of it is whatever be your fields, we can select the fields in using your normal pandas. That is second and third field I am considering it for our purpose. That is age is a second field, and third field is nothing but your estimated salary, and fourth field is nothing but a Y. So your independent variable is X and your dependent variable is your Y. So Y depends upon the X. Y is depending on two variables of a X. One is on age, and another is on an estimated salary. Based on this principle, we start working on it. Before working on this principle, it is required to have, this is the actual part of your machine learning, where in the machine learning part, in statistical part, when we do it, we take up a data, do some analysis, show the output. In linear regression, we gave you some data. We said that the data is linearly having any, either it could be regression, we will be able to find it out or not. We saw about the given value of your X, Y, and we are able to find out the Z value. Like that, we are able to do it. This is all statistical part. While we'll come to some kind of a machine learning algorithms, where we have to split those two data about it as a test data and the trained data, where we'll be training the data and use that trained data, build up a model. Based in that model, we have to use the test data and we have to find out the accuracy part or a predictive part of it. That's the way the logistic regression works about it. So this logistic regression, when we talk about it, we use a sklearn model to select the train and split method. This train and split method, we need not worry about it. That is whether we give 1,000 data or 10,000 data or 1 lakh data. This train and split is a kind of a function name which is being imported from a sklearn, whereas it will split the data. 75% data will be considered as a trained data and 25% of the data will be considered as a tested data. Or based on this principle, it will fit enough the transformation, corresponding transformations will be done. What does this transformation refers for is called as a feature scaling. What does this refers for here is, suppose you got a data, got a gender, whatever we added earlier, gender, ID and other things over there, all that should be a numerical data, accordingly it should be transformed. So therefore, all those data will be transformed automatically, for which we use a function which is being available in your sklearn pre-processing, so that the data will be fit enough. Then once those data is fit enough, then we'll be able to do the testing. So that is the part in which is being used as a trained data and test data. So 75% of the trained data will be taken and 25% will be taken as a trained data. Similarly for Y and Y test and Y this also. Then we use a logistic regression is an equation or in a package or in a function name, we use it directly. So we use logistic regression and this being stored in an object called classifier, where we fit enough for X train and Y train. So our model is being used, or a logistic regression equation is being built up using X-train data and Y-train data. Now we ask them to use those X-train data and Y-train data on which a logistic regression model is being built up. Use those data for X data and predict the Y data. So that is the way in which it is being happened. Please, if you see it upon here, then only you will be able to understand it. So I have built up the data based on this Y predict, and we have finished this. That is what the logistic regression is being made. Equations are being built up for X test data and Y predict data. So now, based on this, whether if I give a new age data and estimated data, whether this new age data and estimated salary data, whether this person will buy this goods or not. This is the next question which we have to answer. So for that purpose, if I take it up like this, suppose I run this over here. This is the first. Just I am running it. Why means, suppose if I run this, you are able to see a new age 23, estimated salary 93,000. Whereas in prediction part, this classifier dot predict, because we have predicted all those part over here using X test data, where the predicted data are all being stored. Now the model is ready to predict any data. So the new data I am giving you to the setup of that is new data is being provided to this equation, whether we are able to get the output or not. So new age I am putting it as a 23, and estimated salary I am putting it as a 93,000. Whether it is able to show me a classify it as a predicted stock index price. Now it is showing it as a 1. Now what I will do here is I try to run this from the part of here. It is running. Yeah, it has run. Now I am running this part. Now I am going to change. Now I am going to change. It's still running. That's a thing. That's the reason I am not running that polyfit 2. If I run this, it will take a longer time than this. Oh, error. Warning. It's a future warning. So now I am running this part in which I am just going to make it as a 12,000. Okay. Whether this stock index price is going to be changed or not. No change. Whether this person's name, if I'm changing it over there in 19, let me see it. The same thing is coming. Let me check it up over there again, please. Whether this is correct or 12,000. Yeah, purchase type is showing this one. 0 it has to show. Let me run this again. No, somewhere else the problem lies now. It is not this one. Okay, let's not worry. So let me find it out, please, whether it is a thing which has run over there or some errors are coming over here. Let me check it up over there again and come back to you tomorrow morning on this part alone. So this is a way in which we predict up and do it over there, where we use a logistic regression and classified fit is going to be creating a model for logistic regression. Based on this, X test data is going to be given and corresponding Y predictive data will be made out. This classifier part will be helping us to predict for the new set of data which we are going to input it. For this purpose, it is showing me 1 only. It has to show for lower salaries, it has to show 0, and for higher salaries, it has to show 1. That's the way it is being, the predict model is being going to be. Yes. Is for any logistic, if this one is going to be there, that is what a dependent variable is going to be having any what we call as a true or false or kind of variables of either 0 or 1, then we have to go for a logistic regression. So based on this principle, this is things which we have been going to explain it. What are the things which we are saying it about here is mean, median, mode, which was being explained by Sendil Kumar about it, for which we have used df.describe, which will talk about a minimum, maximum first quartile, second quartile, and third quartile, and median also, and mean also. And second part here is correlation, that is coefficient. And then we talked about the skewness and the kurtosis. And we will be able to find out some data which is having a correlated. You need not be having a skewness and the kurtosis being equal, but the normal distribution of skewness kurtosis was being holding good for this data set, wine data set. And when we came back to the linear regression, at one part, you have been able to see which are the data being the regression. We'll be able to see the good regression between the different variables or different fields, and where we find out that it's for pH and the density over there. And then when we started doing about the multiple linear regression, we used certain packages in which we are able to find out a linear regression stats model and sklearn model when we used it for making it out a linear regression. Now later we got into a logistic regression where we used social networks media, where we talked about the age and we talked about the estimated salary, and based on those two fields, whether we will be able to make out what we call as whether it could be purchased or not. So based on those principles, we are able to see whether logistic regression could be used. If the variables, if the dependent variable is going to have a kind of a true or false or a 0 or 1, in that case, we should be able to use a logistic regression. If linear regression or a multiple linear regression, it could be used for any set of data. So these are the overall plans in which we are able to see about till the logistic regression. Here another case study which we want to do it over there here is the Markov chain model, which will be very useful for studying about the different states from one state to another state when we are moving it, whether the transition period or transition matrix when we define it, whether the business model itself could be changed or not. That is the way in which it is going to happen. So now Senthil Kumar will be explaining it that part alone. Then we'll be going with the simple coding part to understand those things.
Markov process, a stochastic system, family of random variables, x of t and for n equal to 1, 2 and so on is said to be a Markov process if the occurrence of a future state depends on the immediately preceding state on it. Thus, if t0 less than t1 less than so on tn represents the points in time, and the Markovian property is given by probability of x of tn is equal to xn given x of tn minus 1. It is not fraction. Xn given x of tn minus 1 is equal to xn minus 1 and x of t0 is equal to x0. That is, the probability of the current situation depends upon the preceding one, not on the past data. Okay, the above result can be represented by a matrix called transition probability, which represents the conditional probability of the system being in the state xn at time tn, where n represents the state n. And it was given that it was the state xn minus 1. Xn minus 1 is previous one. Suppose we apply n equal to 1, I get it as x0. Here it becomes x1, 0 state to first state, which is the transition probability, which can be represented in the matrix form. The transition probability matrix, which is represented by TPM. A TPM is a square matrix. It's of order n that summarizes the transition probabilities for a given Markov process. A Markov process can be taken as a Markov chain if it takes a discrete value. The states the form n equal to 1, 2, 3. It's a discrete form. It is called as a Markov chain. The rows identify the current state of the system being studied, and the columns identify the alternative states to which the system can move, which can be represented in a matrix form. Here I represent the TPM matrix. Here E1, E2, and so on represent states, and P11, P2, and so on represents the probability. So P11, P1, sorry, not 2 ones, 1, 2. Okay. So next, second row, third row. The main condition for is the summation of the probability must be equal to 1. That is, the row wise adding should be equal to 1. I demonstrate a small example. Three students are playing. 3 students are passing the balls to each other. The first one is passing the balls to the second one, and if that can be represented in a form of a matrix form. Okay, so it is called as a TPM. So if for the first one passes the balls only passes to the ball to second and third one means, then the TPM value is P1 becomes 0, P12 becomes 0.5, and P13 becomes 0.5. So the summation becomes 1. This Markov model can be applied for all the business purposes, because in statistical model, it is restricted only to a fixed limit. If you go on beyonding the convergence of data, that is for long period, for long transition period of 1 year. If you take n in terms of days, it take for 365 days. If you take n in terms of weeks, so we can go for the Markov process model. That can explain the case studies.
Cooling. On the cooling with Pepsi and Coke.
Pepsi Coke. Here we have taken a 2x2 states. That is, first row is 0.7, 0.3, second row is, excuse me. Here I take two states, Pepsi, here Coke. Next page.
Slow. Slow. Practice. Coding.
The first is Pepsi, next one is Coke. Coke. Okay.
Pepsi. 0.7. 0.6. 0.5.
Okay. This is a transition probability matrix. See here, the summation of the row values takes the value 1. That is, a customer on a prolonged investigation of more than, for maybe for 10 weeks or 20 weeks. A customer who consumes Pepsi at the first time, the next time he goes to Pepsi, the chance is 70%. If he goes from Pepsi to Coke, means he takes 30%, which can be represented in probability form as 0.7, 0.3. Whereas if we take Coke, means the next time he takes Pepsi, the percentage will be 60%, that is 0.6. And Coke, if he consume Coke, the next time he uses Coke means 0.4. This is the data collected for a prevalent for a very large data, or for at least minimum 20 weeks or 20 days. Okay, so this can be taken for a problem in a long run. For n equal to, we take off for n equal to infinity, when this it converges, how the brand and how the company will have to maintain the customers for the particular brand. If we take this as like situation, means based upon marketing, everything. Good. Here, that is a matrix given what we have done, 0.7, 0.3, this is 0.1, 0.9. That is a transition probability matrix. Here, A represents the current state at prevailing the current situation. Now, the rate for Pepsi is 0.55 and Coke is 0.45. If in normal calculation, it's very difficult to make this calculation because in manual calculation, we can go for 2 or 3 calculations. If we go for the iteration, the current stage, if we go for when this get converges. After on, going on for more than 15, more than up to 34 iteration, up to 32nd iteration, it takes this. The resultant probability will be 0.25 for Pepsi, take 0.25 and Coke will be 0.75. The code will be explained this.
See, if you look upon this, Sir was explaining it as Pepsi and Coke. Pepsi is Pepsi to Pepsi people. Those who are taking a Pepsi and being in the Pepsi, it's 0.7. And Pepsi to Coke is transition period is 0.3. Whereas Coke to Pepsi is 0.1 and Coke to Coke is 0.9. This is the transition matrix in which it is being given. If you observe it very keenly, 0.55 and 0.45 was shown. That is, the dominance was given by a Pepsi at the staging point, but the transition matrix being given after the study by the marketing team, which mentioned that the transition here is 0.7 for Pepsi to Pepsi and Pepsi to Coke is 0.3, whereas Coke to Coke is 0.9 and the Coke to Pepsi is 0.1. But the starting of the market, if you see it, the Pepsi is having a dominant market than Coke, but after doing some calculations, np.a, this is nothing but your numpy, where we are doing some kind of a dot product, which is being, it's a linear algebra based concept, whereas dot product, when we do it upon a, t, it's a simple matrix multiplication, nothing else more than that. So when this part is being done and it is being recursively happening, that is recursion is being taken place over there. If you look upon this, A is nothing but your resultant matrix and T is nothing but your transition matrix. This is 2, 2. This is 1 row and 2 columns over there. So that we are able to do kind of a work of the matrix multiplication on a dot product of that, and that is 0. The results of result of the matrix will become an input of the next matrix, and the result of the next matrix will be input of the next matrix, and so on. When we done it over there in this part, it is after the 34th iteration we are able to see the standardization part of it. It becomes very standard. That is 0.25 will be Pepsi's market value, whereas 0.75 will be a Coke's market value. But when we saw about that starting point, when we saw the starting point, we see that A is what we call it as a 0.55, whereas Coke is Pepsi is having a higher market than the Coke. But 34 iterations, it could be a period of 34 months, or it could be a 34 weeks, or it could be anything else. That is, within that period of time, some kind of a marketing strategy is being applied, such a way that is after the 34 iterations, we are able to see that dominance is being done by the Coke and the fall in the market by the Pepsi. This one is the major part of a Markov chain. Is a simple example, very, very simple example of your market chain. When we are able to see about the transition matrix, we are able to define it. Then Markov chain helps us to study about the next state, not the previous state. Next state from the present state. When we look upon the present state, when we are in the present state, when we are looking upon the future state, what will be the future states in such a way that we are able to sustain in the market or not? These things we are able to decide it and find it out easily. So this is the part or a simple application on the Markov chain. This is a small example of that. So this is all the simple examples of the application part of your basic statistics and some model, which we are explained it with some kind of a case study. There is one more major case study. It is there with us now, which will be talking about completed data analytics. Data analytics means all those data available over there. Data, you are 5 minutes. You will say what it is, what and show. That is, this will be a new way of approach. CSV. We will take next 5 to 6 minutes to say what is what. Then later we will also share with this file over there with you all. See, in this, it's a very simple case study on data analytics is being there. Just I'll say about the field name, and fastly I'll say about the output and summarize it immediately, because it's being for not more than 5 to 6 minutes, please. If you see about that, this is New York City's traveling completely. This runs about more than, it's 74 MB file of more than, say, about 6,95,000 data, which is a real-time data, which we are taking it over there. Of 7,29,000 data is being here now with us. But if you look upon this, there are two vendors, vendor 1 and vendor 2. And this vendor 1 and vendor 2 is having a set of what we call cars or city cars like a Red Taxi or Go Taxi like that. These two vendors are being there. What is the data available to you? Data provided to us here is a pickup date and time, drop off date and time, how much passengers are being there, and where does they picked up at longitude and latitude. They are not talking about which place or anything. Latitude and longitude of a picking up, and drop off a latitude and longitude are being given, and what is the duration time in seconds they are given. That is, duration in seconds they are given you, and drop of this they are giving you. Of this 7 lakh data, now they are asking you to make an analytics based on this principle. So you know the statistics part of it, and you know the data set of it. How do we make it? That we have to think and do this one. Some part of the work only I'll share with you now with this real-time data. Just a coding part, I'll take it up faster, and within next 5 minutes, I'll be finishing it out. Coding part. See, coding part of this is pickup. We have been provided with only ID number, vendor's ID, pickup time, drop off time, how many passengers are being there, and where does the place in which longitude and latitude place where they picked up, and where is the latitude longitude place where they have been dropped off, on how much is the seconds they have done it over. Then what is the analytics part we have done on this? Forget about this. This is the usual part which we say about it. The shape means we find out the number of fields over there. There are 7,29,000 data, 322. Taxi data types. What are the taxi data types are having it? Float, integer, object, and other things over there. Timestamp, what we call it, was over there. And the columns which we have got it over there. Now, I'm skipping up all this part because minimum, maximum, mean, median, everything, quartile, 25, all those things are being explained in the earlier case study. So therefore, I'm skipping it up, all these things, going to the major area. How many vendors are there? 2 vendors are there. In these 2 vendors, which vendor has done more travels than this? That is about 7,29,000 data. In this records, which vendor is done how many trips over there, how many records more than that. That is, if you look upon this, we got 3,38,841 trips is being done by the vendor 1, and 3,90,481 trips is being done by the vendor 2. Second, when we look upon that, if you look or you put it plot over there, that's the plot in which we use a matplotlib to find it out and do that. Then what is the total time travel by the vendor ID? Who has traveled more time over there in terms of a seconds? Because they are given duration as a seconds. So which vendor is taken more time of this 3,38,000 of a trips or 3,90,000 of a trips of vendor 2? Who has done more seconds in terms of seconds over there? So if you look upon that, driving hours of all vehicles of all trips of each vendors is being given to you. That is vendor 2 and vendor 1, and total type of a trip being made by this vendor 1. So if you are able to see it, vendor 1 is done lesser than the vendor 2. Second part here is, what is the number of hours they have done it? It is all in seconds. So what is the number of hours he has done it? So if you look upon that in terms of a seconds or in terms, it's 80,000 hours place. It's a small mistake here. And here is around the 1,20,000 hours is being made by the vendor 2. Then see, pick up latitude, longitude, and drop off latitude, longitude is given. Then how do you calculate a number of kilometers being traveled? That's the next question to be answered. This is a part of the data analytics over there. You are given with the provided with the data set where pick up latitude and pick up longitude is given, and drop off latitude and drop off longitude is given. Starting 2 points are given. Is it possible to apply Euclidean distance to calculate the normal root of x2 minus x1 the whole square plus y2 minus y1 the whole square? Is it possible to apply that formula and calculate a normal distance? No, you can't do it, because our travel, what we call it as our earth is in a spherical shape and other over there. Therefore, our dimension of calculation to be done in a different way, and that is being done using this formula over there, and which is able to give me a distance between a kilometers, which is being stored in a different places, which gives me a driving kilometers of a vehicle of all trips. If you are seeing it, you can see that vendor 1 kilometers in terms of a kilometers is able to clear it around nearly about say about 19 lakh, whereas vendor 2 is able to score around 21 lakhs of kilometers. Whereas this type of a data is not being provided. These data has to be pulled out from the given data set of pick up latitude, pick up longitude, drop off latitude, and drop off longitude, where it should be done based on the principle of a geometrical feature which should be known from a mathematical part of it, and which we have done it over there to show off this kilometers. So number of passengers being traveled in vendor 1 and vendor 2, that's also being shown here. The beautiful concept here is you are given a pickup time and a drop off time. Pickup time and the drop off time, when they are given it, there is only one field. Pickup time and drop off time, pickup date and drop off date, only field. Drop off date contains date and time. Pickup date contains date and time. So first we have to split up those things, and we have to say in which day more travel is being done and which month there is a more travel being done. All those analysis has to be done. Since I am taking you on 1 more minute to finish off this, so that I directly go over there, show only the result part of it. Forget all these things. This is all the calculation part, which we have done it a lot. We've done a homework on that. This year, month, year, date, hour, minute, second, everything to be splitted by a coding part, so that you are given a very limited fields. From that very limited fields, only a statistical part can be applied. Using a Python packages, we can elaborate that fields, bring up a more analytics on that, so that we are able to do a very good analysis, which I show you now. If you see it, see the driving kilometers of vehicle of all trips, which is the day in which more travel is being done. That is, it is on Friday, it is on Saturday, and it is on Thursday. This is one of the important part in which we are able to understand it, where this type of data is not provided by your data set. This data has to be pulled from this data set, and we have to make an analysis, for which we have done a lot of coding part of it for an analysis, but that those things are being here now. That is the thing I told you, I'll be sharing with this data set in a Google Drive, because data set is quite very large, so that you can use it over there. Then second year is people travel more on Friday, Saturday, Thursday compared to other days. Then second year is when you look upon this 24 hours of a travel, in which timing the more travel is being done. If you look upon it, you are able to see that 18th hour and 19th hour, that is in 6 p.m. and 7 p.m. the peak of traveling is there. Which vendor, those analysis also could be done. Which vendor, which timing is also being done, and other things also. And second part of this analysis here is, if you look upon this is one of the beautiful analysis. A number of weekdays based on vendor ID and vendor 1. In weekdays, we have to calculate Monday, Friday, Saturday, and everything. Which hours, orange color refers for a vendor 2, and vendor 1 is in a blue color. If you see that in all weekdays, number of trips being done on weekdays, that is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. All these 7 days. Of course, I should have put it over here, Monday, Wednesday, like that, so that you should have been understanding better way. So if you are able to see that vendor 2 is doing a more travel than this vendor 1, and you are able to understand it on all days during peak and odd hours also. Then second part, when we look upon this, we are able to see that is pickup and day and the drop of day, there's no differences, we find it over there. There's no information available over there. So which month there is much more travel? In which month we are able to see that there are more travels being done. So that is in the month of March, you are able to see there is more travel being done. In the month of April is being more travel is being done. That is from January to June only they have provided a data for 7,29,000 data being provided for vendor 1 and vendor 2 in between the month of January to June. All those data are being taken and being are able to provide it. See that we have been only provided you with the limited number of fields. That is vendor ID we have provided, pickup date time we have provided, drop of date and time we have provided, latitude we have provided, longitude we have provided, number of seconds, duration in terms of seconds we have provided. Only 6 fields we have provided. But we have to make an analysis in such a way that all these things we are able to do it. Statistics gives you the information, and this Python's packages, we are able to make data analytics on this principle. That is a major part of the work which is being done. One of the part of the work for the data science. Data science is where we do a lot of algorithmic work to see the patterns, to see the extraction, rather than this. Now we have done a very limited part of it, where it can be done much more formula better way. When we do it, we are able to see the kilometers part. We are using ACN matrix over there to calculate a geometrical figure, to calculate the latitude and longitude being provided, means distance we are able to calculate it. So altogether, what is the conclusions of these packages? That is, there are 11 fields is being given. Trip duration is the target variable. Then 3,38,000, 3,90,000 is a vendor 1 and vendor 2. Total time taken is being provided, and total trial time taken in terms of hours is being provided. then kilometers is being calculated, and we are able to see SCN method to calculate the distance is being used, and we are able to see that latitude, longitude, and other things have been shown. Number of passengers traveled by a car we are able to show, and we are able to show which vendor traveled how many kilometers directly. And apart from that, we are able to show you which month and which time all those things have been taking place. These are the patterns in which we are able to see the month travel, all days have been travel, and so on. So these are all the overall glance of the speedway I'm doing is overall glance of about what we call data analytics. Apart from the statistical applications, we are able to do these things. This is a simple example which we are given it. We'll be sharing you this real-time data with you all soon. That is in tomorrow, today itself if possible. We'll be sharing it in a Google Drive. In your email IDs, please drop what we call the download it, put it in your machine, use either Jupyter Notebook or Python any editors to run the program and see it. Anything else, please, if you want it. Just sorry for taking 10 more minutes with you. Any questions and other things or there, please, we welcome it over there. 84 participants. Any questions, please? If not, we will be winding it up. Tomorrow's session, yes, please. Yes, so tomorrow's session will be Navaneethan, who is being very good at not only coding part of your Python languages, and is very good at what we call as he was a lead course instructor from FEMDEC, one of the companies at Poland. Apart from that, he is a dean of the Coimbatore Artificial Intelligence, where he is doing a lot of work in artificial intelligence area. Where he also a developer for a company at Texas. Apart from that, he is a consultant for Ioni Technologies in India, and he was a research and development consultant for Krish Technologies at Coimbatore. He will be talking to you tomorrow with us, where he will be available for all the 3 sessions. All the 3 sessions will be handled by you. So this is all the information which I pass on to you about tomorrow's session. We'll be meeting him tomorrow with you all. Anything else you wanted, please, you can ask me now. All those materials will be shared with you all. PPTs also will be shared. Instead of PPTs, all the recorded sessions itself we are providing with you. So it will be there with you all. So tomorrow at 9:30, we'll meet you all, please. GitHub plus how to contribute. Now we will be sending it to in a Google Drive, please. That later we'll put it up with GitHub and other things. So anything else, please? Okay. Thank you all. We'll meet you all tomorrow. Thank you. See, there is a question where we can learn more about it, sir. See, there are certain sites in which we are having a data sets. Kaggle is one of the things. Tomorrow I'll give you the exact links, please. Kaggle is one of the data sets available, where we take up the data, real-time data are available, where we can download it and we can use this for data analytics. Please listen here one thing, data analytics cannot be taught by anything else. We have to do it and see it. By thinking only it will be coming, whether we can do this data with these fields or not, whether this output is shootable or not, all those analysis will come later only, not immediately. So it will take some time until otherwise data set is available in Kaggle, please. Apart from that, tomorrow we will share some more sites also for data sets. And there is a Stanford University website also where the open data set is available, where you can use it over there. And one more university, if I am correct, it is a University of Newark or somewhere else, the data sets are available. Medical data sets are available. And there is a COVID data sets being available at John Hopkins University, where every data set is being updated, where you can do a lot of work on the COVID analysis. Anything else, please? Today we'll be sharing you with you all feedback. Please send back. Already it is being shared. Please send the feedback, please.